So in this video we're going to talk about the exponents, more specifically negative and fractional exponents. So let's start with a problem. Let's say we have 3 to the power of 4 and that's divided by 3 to the power of 6. Given what we know about dividing numbers with exponents that have the same base, we can just subtract the exponents from each other. So we leave the 3 and we subtract 6 from 4, giving us -2. So what does this -2 mean? Well, if we draw out the problem in fractional form, let's say we have 3 to the 4, that means 3 times 3 times 3 times 3, so 4 times. So in the numerator we have 4 3's, and in the denominator we have 3 to the 6, so 6 3's. And when we have this, we can just cancel out the multiplication and the division. This leaves us with just 1 on top and 3 multiplied by 3 in the denominator. Now, because we have 3 times 3, the same number multiplied by itself, we can write it in exponential form. So we can write this number as 3 to the second power, which means 3 times 3. Given this, we can see that -2 simply means the reciprocal of 3 to the second power. When we see a negative sign, we just put this number in the denominator. We put the 1 on top and put the 3 squared in the bottom. We could have also worked this problem another way. Let's say we have the same problem, 3 to the 4th divided by 3 to the 6th. Given what we know about division and multiplication, we can change this division problem into a multiplication problem by multiplying this number by the opposite of this. So what is the opposite of 3 6? We have 3 6. The opposite would be the reciprocal, which is 1 to the 6th power. And we already know that 1 over 3 6 is the same thing as 3 to the -6. So we change this division problem into a multiplication problem by multiplying by the opposite. So we now have 3 to the -6. And we already know how to multiply numbers with exponents which have the same base. We just simply add the exponents. Then we simply add the -6 to +4, which will give us -2. As you can see, we got the same answer. We just changed this division problem into multiplication problem, and then we add the exponents. So let's work another problem. In this problem we see that we have 2 division signs. So the first thing we're going to do is change this division into multiplication. And we already know how to do that. We just turn this into a reciprocal. So first we leave the 5 to the 6 as it is. Then we multiply by the opposite. And the opposite of 5 to the -4th is 5 to the 4th. We multiply again. We leave this as it is. Change this into a multiplication problem, and then we multiply by the opposite of this, and the opposite of this is 5 to the -4th. Now we simply add up all the exponents, which will give us 5 to the -1. And we know what 5 to the -1 means. The negative means it's a reciprocal of 5 to the 1, which means it's 1 to 5 over 1. And 5 to the 1st power is the same thing as 5. So our answer is 1/5. So let's work another problem. Here we see that we have two division signs. And whenever we have the same bases, we don't divide, we just change the division into multiplication and then add up all the exponents. So the first thing we're going to do is change all these division signs into multiplication signs. So we leave the 3 to the negative fifth as it is. Change this to multiplication. What is the opposite of 3 to the negative 6? Well, that's 3 to the 6. We leave this one as it is, 3 to the fourth. Change this sign into multiplication and multiply by the opposite of this, which is 3 to the negative 2. And then we leave this one as it is. Now we simply add up all the exponents. So we have negative 2, negative 3, which is 5, and we have another negative 5, so that's negative 10. And we have a positive 10, which means the answer is 3 to the 0 power. And we know what 3 to the 0 power is. Any number raised to the 0 power is 1. So let's now move on to fractional exponents. And let's just start with a problem. Let's say we have 4 to the 1/3, and that is multiplied by 4 to the 1/3, multiplied by 4 to the 1/3. Now, given what we know about multiplying numbers with exponents which have the same base, we can just add up the exponents. So we leave the base and we add up 1/3 plus 1/3 plus 1/3 gives us 3/3, which is just 1. And 4 to the first power is simply 4. Now here we can see that we have the same number multiplied by itself 3 times, which is basically like saying 4 to 1/3 cubed. Now, given what we know about cubes, these will just cancel out, given it's just 4. That means that 1/3, 4 to the 1/3 simply means the square root of 3, or the cube root of 4 multiplied by the cube root of 4 multiplied by the cube root of 4, which again will just give us 4 once we perform. Now taking the cube root of something, then multiplying that something by itself 3 times will cancel out. It's the same thing as saying the cube root of 4 then cubed. Cubed means multiplied by itself 3 times, which is the same thing, which will basically cancel out and leave us with 4. So from this we know that 4 to the 1/3 power is equal to cube root of 4. These two are equivalent, which means that 1/3 power is the same as saying cube root of that number. Let's work another problem. Let's say we have 9 to the 1/2 power, and we know from before that 9 to the 1/2 power is the same thing as square root of the 9. Because this is a square root, we don't need to put the 2. And the square root of 9 is 3, because 3 times 3 is 9. So from all this, you can probably see the pattern that all a fractional exponent means is the root of that number. If we had 9 to the 1/3 power, this would mean the cube root of 9. If we had 9 to the 1/4 power, this would mean the 4th root of 9. If we had 9 to the 1/5 power, that would mean the 5th root of 9. The denominator of a fractional exponent is the root of that number. So let's work another problem. Here we have the same base, and we have the root of 3, and we have a numerator of 2. Given what we know about multiplications of numbers with exponents that have the same base, we can just add the numerators together. So we keep the same base, we add up the numerators, which will give us 6. Now we can simplify this, which will give us 3 goes into 6 2 times, 3 or 5 to the second power. From this we can see that the numerator of the fractional exponent is the power of that number, or the exponent of that number. The 2 that we have here is a 2 that we have here. The 3 goes away because taking the root of something and then multiplying it 3 times, which is the same as cubing, is cancelled. So we're just left with 5 squared, which means that 5 to the 2/3 power is equal to the cube root of 5 to the second power. These two are equivalent. And you can see that because if we multiply this 3 times, that's the same as cubing it. And the cube and the root, the cube root will cancel out, giving us just 5 squared. So let's work another problem. But let's work a problem that we've already looked at. We had 9 to the 1/2 power, and we said this means the square root of 9. And we were right, but let's look at what actually happened. From what we know above, the 2 means the square root, and the 1 means the power. So we actually had the square root of 9 raised to the first power. Square root of 9 is 3, so it's 3 raised to the first power, and anything raised to the first power is that number, which is 3. So let's work another problem. Let's say we had 25 to the 3/2 power. Now we know what the denominator means. That means the root of this number, and 3 is the power of this number. So we can rewrite this problem as the square root of 25, and then all of this is cubed. So the square root of 25 is 5, and we keep the 3. Now the 5 cubed gives us 125, because 5 times 5 times 5 is 125. So now let's work another problem. Let's say we have 64 to the negative 2/3 power. Here we have a fractional exponent and a negative. So we can translate this negative 2/3 into, we know that the negative means the reciprocal. So we put a 1 in the numerator, and now in the denominator we have the root of 64, the cube root of 64, and all of that is raised to the second power. Continue to work the problem. The cube root of 64 is 4, and we still have the second power. So now we have 1, and 4 squared is 16, because 4 times 4 is 16. So 64 raised to the negative 2/3 power is the same thing as 1/16. This is the numerical value of this. So with all this, we know that the numerator and the denominator of a number, the numerator means the power, and the denominator means the root of this number. Now let's take a look at some special cases. Let's say we have negative 2 raised to the second power, and we have negative 2 raised to the second power. Will the answers to these problems be the same? Well, let's start with the first one. From the order of operation, we know that we have to take care of the exponent first. So we square the 2, giving us 4. And then we also have a negative, so that means we have a negative 4. Now this problem is a bit different. Here the negative 2 is contained within parentheses. And from the order of operation, we know that we have to take care of the parentheses first before we do anything else. So because this is contained in the parentheses, we square this whole thing. And negative 2 squared is 4. Because negative 2 multiplied by negative 2 gives us a positive 4. So let's work another problem. Let's say we have negative 27, and that is raised to the negative 4/3 power. So first we put this problem into fractional form, and then we solve. So we know that negative means the reciprocal. That's why we put it in fractional form. So we know that all this goes in the denominator because of this negative. And in the denominator we have negative 27 is rooted to 3. So we have the cube root of negative 27. Negative 27. And then all of this is raised to the 4th power. So what is the cube root of negative 27? Well, we know that the cube root of 27 is 3. And then we just add the negative. So we have, in the denominator, we have negative 3 raised to the 4th power. So now, what's negative 3 raised to the 4th power? 3 multiplied by itself 4 times gives us 81. So this simplifies into the fraction of 1/81. So let's work another special case problem. Let's say this time we have a fraction. We have 4/9, and that is raised to negative 3/2 power. What we can do is continue what we've done before, which is take the reciprocal because of this negative, giving us 4/9, giving the square root of 4/9 raised to the 3rd power. We have the square root here, but that's kind of too complicated. What we can do instead is exchange the numerators and the denominators to get the reciprocal. So we put the 9 on top and the 4 on the bottom. So we have the 9 on top and 4 on the bottom, and now we get rid of this negative because we're taking the reciprocal. So now we transform this problem into this, and this is much more manageable. So now we realize that, so given what we know about fractional exponents, we know that the second number, the denominator, means the root. So we have the square root in this case, so we can transform this problem into something like this. We have the square root of 9/4, and that is raised to the 3rd power. We also realize that square root of 9/4 is the same thing as the square root of 9 divided by the square root of 4. And of course we also have that cubed. Now we simplify the square roots. The square root of 9 is 3 raised to the 3rd power. Then we have the square root of 4, which is 2 raised to the 3rd power. 3 cubed gives us 27. and 2 cubed gives us 8. So now we have a fraction that we can simplify, and it simplifies into 8. It goes into 27 3 times, and then we have 3 left over, so we have 3 8s left over. So this simplifies into 3 and 3/8.